On this video, we're going to work some more problems to get ready for the chapter 9.6 to 10.2 test. So we see here a couple functions represented by their graphs, the yellow function f of x and the green function g of x. So we are going to try to find f divided by g of negative 2, which means we're going to take f of negative 2 divided by g of negative 2. So for f of negative 2, we go to that yellow graph, and at negative 2, we see that, whoops, I lost my pen. Okay, I'm back. So at negative 2, I wanted that to be blue, I missed. That's going to be positive 2, and g of negative 2 looks like that's going to be negative 2 as well, negative 2. So 2 over negative 2 is a negative 1, and that's going to be f divided by g of negative 2. F times g of 2 means we're going to take f of 2 times g of 2. So f of 2 is going to be the y value there, which looks like 2, and g of 2 is going to be the y value there, which looks like negative 1, and so that is going to be a negative 2. Okay, now we're going to try to graph f plus g of x. So that means we're going to go point by point, and we're going to look for what is the value of f and g. So at negative 1, 2, 3, at negative 3, the f is 0, and the g is 1. So 0 plus 1 will make that 1. So we're going to get a point for x equals negative 3, a y value of 1. At negative 2, we kind of saw that it looks like already. That's going to be a positive 2 and a negative 2. Those are going to combine to be 0, so we add those together. We're going to be at 0. At negative 1, f is going to be a negative 1, and g is going to be a positive 1, so we're still at 0 there. And at 0, f is 0, and g is positive 1, so that'll take us back up to 1. At positive 1, f is 2, and g is 0, so we're going to be at positive 2. And finally, at 2, f is positive 2, but g is negative 1, so we're going to come back to 1. We'll connect these with straight lines, and that is our graph of f plus g of x. So that's the blue. Now we're going to switch to red and do f minus g. So again, we're going to go point by point. So f, which is 0, minus the g, which is 1, will be a negative 1. So that's going to give us negative 1 when x is negative 3. And the f is negative 2 minus the 2 will get us all the way down to negative 4. I'm going to have to extend that a little bit. So we're all the way down here to negative 4. And at negative 1, f is negative 1 minus 1 is a negative 2. At 0, f, which is 0 minus 1, is a negative 1. At 1, f, which is 2 minus 0, is all the way up to 2. So we're going to have a shared point there. And at positive 2, f is 2 minus a negative 1 is going to be a positive 3. And we'll connect these with straight lines, more or less. And that's going to be our y equals f minus g of x. Okay, now we have f, the white function, is the exponential 3 to the x, and g is the linear 2x plus 1. So f of g of 1 means we're going to take f of and g of 1. Let's see, g of 1 is going to be 2 times 1 plus 1. That looks like 3. And f of 3 is going to be 3 to the third, and that's going to be 27. For g of f of negative 1, we need to know what is f of negative 1. Let's see, f of negative 1 is going to be 3 to the negative 1. That's going to be 1/3. So we're going to have to take g of 1/3, and g of 1/3 is going to be 2 times 1/3 plus 1. So that's going to be 2/3 plus 1, and we can either think of that as 1 and 2/3, or we can call it 5/3. Either way is okay. Okay, so f of 1, so we're going to first plug 1 into f. That's going to be 3 to the first is 3, and then we're going to get 3 to the third, which is 27. G of 2, so we plug 2 in. 2 times 2 plus 1 is 5, and then plugging in 5, we're going to get 2 times 5 plus 1 is going to be 11. Okay, we're going to simplify these imaginary numbers here. So I squared we know is negative 1, and then I to the third is I squared times I. That's going to be negative 1 times I. Whoops, where's my eraser? So that's going to be negative 1 times I. So far we got a negative I. So that's going to be a negative 1 plus 2I. Now I to the fourth, I squared is negative 1. Negative 1 times negative 1 is positive 1. So that's just going to be 3. And now we got I to the negative 19. Let's see. 1 over I to the 19th. So we know that any multiple of 4, so 19 is going to be 16 plus 3. So the I to the 19th is going to be I to the fourth times I to the third. Now it's supposed to be a times. So I to the fourth is 1. 1 to any power is 1. So that's going to be 1 over I to the third. I to the third we know is I squared times I. I squared we know is negative 1. So that's a negative I. We're going to multiply top and bottom by the conjugate of negative I. That's going to be a positive I. So that's I times 1 on top, and negative I times I is a negative I squared. Since I squared is negative 1, that becomes a positive 1. And so after all that, it's going to be an I. So let's see. The negative 1 plus 3 is going to be 2, and the 2I plus I is going to be 3I. And there is our answer. The second one, now the yellow one, to divide two complex numbers, we're going to multiply top and bottom by the conjugate of the denominator. So we're going to change the sign of the imaginary part and leave the real part as it was. So multiplying 2 times 3 is 6, 2 times I is a 2I, 3I times 3 is another 9I, and 3I times I is a 3I squared. We'll come back to that. In the denominator, we're going to get the difference of two squares, so that's 3 squared minus I squared. Okay, let's see what we can do. I squared is negative 1, so that's going to become negative 3, plus the 6 is going to be 3. 2I plus 9I is 11I, and we're going to get a 9 minus negative 1 is a plus 1. That's going to make our denominator 10, and we're going to write that as A plus BI. So there is our complex number. So a complex number divided by a complex number is still a complex number. Okay, so let's do a little distributing. This is going to be 12 minus 3I. Then we're going to get a negative 2I times 3 is going to be a negative 6I. And then a negative 2I times negative 5I is a positive 10I squared. Now I squared is negative 1, making that negative 10. Combining that with the 12 makes 2. The negative 3I minus 6I is a minus 9I. And there we have it. And another really tough inverse function. So I'm going to graph this too because I think seeing what's going on really helps to decide what we've got. So we know that y equals x plus 3 squared is a parabola that opens up and has been translated left 3. So I'm going to go to negative 3. Now it won't be the entire parabola because we only want values of x that are greater than or equal to negative 3. So we're going to get that just the right side of that parabola that opens up. Okay? So now I'm going to change colors here, and I'm going to switch the x and y. So this is y equals x plus 3 squared, and our x is greater than or equal to negative 3. So I'm going to go x equals y plus 3 squared, and I'm going to say y must be greater than or equal to negative 3. I don't know if I'll need that or not, but it doesn't hurt to put it in there. We're going to square root both sides, and so we want positive or negative square root of x, and we'll get a y plus 3. Now we can't keep both the positive and negative, but if we subtract that 3 over while we're deciding whether it should be a positive or a negative, we can get a clue from what we said here. Y has to be greater than or equal to a negative 3, so that means that we want the positive one and not the negative. And so our f inverse of x is going to be negative 3 plus the square root of x, and square root of x has a restricted domain, so I'm going to say x greater than or equal to 0. Now, to graph that, we know that square root of x is the top half of a sideways parabola, so it's going to look something like that, and the negative 3 is going to translate it down 3. So we are going to try to go 1, 2, 3, and something like that. And it may help to see that they are, in fact, going to be reflections in the line y equals x. So the green, gotta go back to green for a minute. Our green function is our inverse, and our blue function was the original f of x. And we can see that they are reflections of each other in the line y equals x. Okay, let's see if we can just graph y equals f of x and y equals f inverse of x on the same axes. So here, I'm going to graph the f in yellow. Now, they don't ask us to find the inverse, so I think if we're careful here, we can figure out the graph without having to come up with an inverse function. So we know that an x squared, the parent function, is going to be a parabola that opens up. That negative is going to reflect it in the x, and then we're going to translate it right 3 and up 2. So we're going to go right 3 up 2. That's going to be our vertex. So I'm going to call that 3, 2. And I'm going to plot another couple of points because I think this will help us with our inverse. And since there's no horizontal or vertical stretch or shrink, we're going to go right 1 and down 1 and left 1 and down 1. So that point is going to be 4, 1, and this one will be 2, 1. And I'm going to draw that parabola. So there's our original y equals f of x in the yellow. I'm going to switch to green for our inverse. And what I'm going to do is just switch the x and y's. So 3, 2 becomes 2, 3. So 2, 3, I didn't plan that very well. There's my 2, 3. The 2, 1 is going to become 1, 2. And let me label that. That's 2, 3, and that's 1, 2. And 4, 1 is going to become 1, 4. So I'm going to have to go up 1, 2, 3, 4, up another 1. So there's 1, 4. So the vertex is still the vertex in both the inverse and in the original. But you can see that we're getting this reflection. Bumped it again with my left hand. It's going to be a reflection. I lost my pen. Let me try it here. Okay, here is our line y equals x, and hopefully you can see that they are reflections of each other in that red line. I think that might be the end of the story. Okay, that's all we got for this one.